Assalamualaikum warahmatullahi wabarakatuh. I'm AMIRAH HAZWANI. I'm going to present about introduction. These experiments explore how gravitational potential energy is converted into kinetic energy using marbles and custom-built roller coaster track. So we can understand how roller coaster works by using something small like marble. If you hold a marble at the top of the ramp, it has potential energy because it's high up. When you let go, the marble rolls down the ramp and stops moving fast. This is kinetic energy or energy of motion. Just like a roller coaster, the marble changes potential energy into kinetic energy as it goes down. This shows how energy moves and changes when something falls or rolls downhill.
Hi, I am ADILAH SYAHIRA binti AZHAR, student with metric number TC24057. To conduct this experiment, we use the following materials: foam pipe insulation, which we cut lengthwise to create U-shaped track for the roller coaster; cloth duct tape, used to securely connect the track section and ensure smooth transition; a measuring tape for accurate height measurement; a cutter knife for shaping the foam; a marble as our rolling object; and a stopwatch to record the time it took for the marble to travel a fixed distance. These materials allowed us to simulate a roller coaster environment and explore how potential energy is converted into kinetic energy. The procedure involves several steps. First, we cut the foam pipe insulation to form two U-shaped channels and join them using closed duct tape to form a continuous thread. Second, we place the marble at various measured starting height along the track. The marble was released and we recorded the time it took to travel a fixed distance of 1 meter using a stopwatch. Each height trial was repeated 3 times to ensure consistency and reliability. Finally, we calculated the marble velocity by dividing the known distance by the average time recorded for the 3 trials. This process helped us analyze the relationship between the released height and resulting speed of the marble.
Next, I'm going to present about the result. From our data, at a height of 0.03 meters, the velocity was about 0.744 meter per second, but at 1.30 meters, the velocity rose to 1.538 meter per second. This shows that the higher the starting point, like the peak of the roller coaster, the more potential energy is available, and the faster the object moves as it converts the energy into motion. This experiment mirrors what happened to the real roller coaster. As the coaster climbs a hill, it gains potential energy. At each distance, the energy transforms into kinetic energy, propelling the coaster forward. In conclusion, our experiment clearly demonstrates how gravitational potential energy is converted into kinetic energy, with higher drop resulting in greater speed, just like the thrilling descent of roller coaster. That's all from me. Thank you.
My name is Alya binti FAHMI. My number metric is TC24030. So today I will presenting about discussions. Number 1 question is gravitational potential energy. So the highest gravitational potential energy was recorded when the marble was released from a height of 1.30 meters, giving it about 0.08 joules. Number 2 is kinetic energy. From the highest measured velocity, the kinetic energy reached around 0.0742 joules, which is much less than the initial potential energy. Number 3 is energy comparison. This difference shows that not all the potential energy was converted into kinetic energy. Some of it was lost through friction and air resistance. Number 4 is effect of starting height on speed. We observed that when the marble started from a higher position, it traveled faster. This confirms the link between height and speed. Next question is number 5, energy on uphill section. As the marble went uphill and slowed down, part of its kinetic energy was converted back into potential energy. Number 6 is, can the marble suppress its starting height? A marble cannot reach a height greater than where it started unless extra energy is added. It simply does not have enough energy to go higher on its own. The last question is number 7, effect on marble mass on potential energy. If we use a heavier marble, its potential energy would be higher at the same height, but its speed would remain about the same because mass cancels out in the energy to speed relationship. Last is conclusions. The experiment successfully demonstrated the conversion of potential energy to kinetic energy in a control setting. So this experiment showed that as the starting height of the marble increased, so did its speed at the bottom of the track. The result confirmed that gravitational potential energy is converted into kinetic energy as the marble moved downward. However, the kinetic energy was always slightly less than the initial potential energy due to friction and air resistance. Despite some energy losses, the principle of energy conservation was evident throughout the trials.